Hey students, today's lesson is on solving equations when there's variables on both sides. So to start off with, we have this key idea. To solve equations with variables on both sides, we need to collect the variable terms on one side and collect all the constant terms on the other side. So the sides with variables on either the left or the right, and then the side, put all of the terms that just have numbers on the opposite side from that. All right, so let's look through this first example. Here we have 15 minus 2x equals negative 7x. So we want all of the x terms on one side and all of the constant terms on the other side. So for this problem, probably the easiest thing to do would be to add 2x to both sides. And the negative 2x and positive 2x will cancel out. So we have 15 equals negative 5x. Then we're going to divide both sides by negative 5. We're left with x on the right and negative 3 on the left. Here's our next example. This time we need to use the distributive property before we take any other steps. So it looks like we need to distribute on both sides of the equation. So on the left side, we'll multiply by negative 2. Don't forget our negative 2 times negative 5 is positive 10. And on the right side, we'll multiply both terms inside the parentheses by 6. 6 times 2 is 12 minus 3x. Okay, now we have a few steps because we have constants on both sides and we have variables on both sides. So there's not exactly one way to solve this. We could go through it in a couple of different ways. I'm looking and seeing that if I add 3x to both sides, I'll end up with positive 1x, which is kind of nice. So I think I'm going to do that. So these cancel out. I have x plus 10 equals 12. Now I need to subtract 10 from both sides. And I get x equals 2. Sometimes we might have an equation for which there is no solution. There's no value of x that can make this true. So we don't necessarily know this when we start, but when we look at this particular problem, let's say we want to get all the constants on one side, so we're going to add 7 to both sides. So now I have 10 minus 4x equals negative 4x. So now if I want to have the x values all on the right, I would add 4x to both sides. And I get 10 equals 0. So there's no value of x that can make this true. So this is an equation that has no solution. And if you get a problem like that, you're just going to indicate that there is no solution. Got a little weird thing going on here. Okay. Sometimes we have equations that have infinitely many solutions. In other words, any value of x will make it true. So let's go ahead and start solving this as we normally would, and we're going to find that we have infinitely many solutions. So it looks like we need to distribute first. Let's see, 4 times 3 is 12 divided by 2 is 6. So 6x plus 4. Now I can already start to see I've got an issue here because 6x plus 4 equals 6x plus 4. It's the same thing on both sides. Let's go ahead and take this all the way through. Let's see if we can get rid of the constant on this side by subtracting. And look what happens. It actually drops off of both sides. So I have 6x equals 6x. I can divide both sides by 6, and I get x equals x. Well, It doesn't matter what x is equal to. X is always equal to x, whether it's positive 1 or negative 54. This statement will be true. So this is infinitely many solutions. All right, so let's look at this example. I've got another little box here to get rid of. Oh well, it doesn't want to go away. All right, so here we have two circles, and they're on your sheet too, and we know that they're identical. And so we want to find out what's the area of each circle. So the first thing is, hopefully we know the area formula is pi r squared. So that means we need to know what the radius is. So the green circle, I have the radius is x plus 2. The purple circle, I see that the radius, or the diameter, is 4x. So I could either set the two radii equal to each other by saying 2x equals x plus 2, or I could set the diameters equal to each other by saying 4x equals 2 times the quantity x plus 2. I'll go ahead and take that option. So here's the diameter of the purple circle, and then let me simplify the diameter of the green circle. And now I need to solve by subtracting 2x. Two x equals 4. Now I'll divide by 2 on both sides. And I find out that x equals 2. All right, so that tells me something. I don't quite have my area yet. I need to find the radius. So I can find it by saying 2 plus 2 is 4 on this one. Or if the diameter is 8, 4 times 2, then the radius must be 4. So either way, the radius is 4. So the area equals pi times 4 squared. And we can just say 16 pi. That's good enough. We can leave it in terms of pi. All right, one more real-life application. Here we have this boat that travels X miles per hour upstream on the Mississippi River. On the return trip, it's going to go a little faster. It's going to go 2 miles per hour faster. How far does the boat travel upstream? So we're solving for X, which is how many... No, we're not solving for x. We're solving for how far it travels, so the distance here. So we're given the miles, we're given the time it takes, and we know that x is the miles per hour. So let's think about this. If x is miles per hour, and then if we multiply that by how many hours, that's what gives us the distance, right? Miles over hours times hours would be miles. So in this case, we can set the distances equal to each other because they're the same. So we can say the distance upstream equals the distance downstream. And the distance upstream is going to be 3 hours times x, because it takes us x miles per hour. 3 hours times x miles per hour. And the distance downstream is going to be 2.5 hours times the speed, which is 2 miles faster. So times x plus 2. Now we can simplify and say 3x equals 2.5x plus 2.5 times 2 is 5. We'll subtract 2.5x from both sides. And we get 0.5x equals 5. Kind of ran out of space here, but divide by 0.5 on both sides. And we get x equals 10, which is miles per hour. And then, of course, the Going downstream, it would be going 12 miles per hour, x plus 2. All right, so that's it for this lesson. Go ahead and try a few on your own, and I will see you soon.